Welcome. Today we are going to learn on how we can use GeoGebra in teaching geometry. We are going to start by drawing different figures. We are going to start by drawing a triangle. You can draw a triangle from this point up to this point. Here it is 3. Click OK. Our triangle is ready. We can now draw. A square from this point up to that point. That is 4 vertices. Click OK. So that is our square. We can also draw pentagon from this point up to this point, and that is 5 vertices. Okay, we are having our pentagon. We can also draw hexagon. You can start from here up to here, and that is 6 vertices. Okay, so we have a triangle, we have a square, we have pentagon, we have hexagon. We are going to find the sum of interior angles of these polygons. The sum of interior angles of these polygons. To start with a triangle, let us locate the interior angles of it. Okay. As we can see, we have 60 degrees in each of 4 interior angles of a triangle. The sum of this will give us 180 degrees. We are going to use this knowledge to get the sum of interior angles of all other polygons. We are going to divide our polygons into enclosed triangle. Let us start with our square. We are going to divide our square into enclosed triangles. Let us get line segment from here, then draw a diagonal from this point up to that point. So we have 2 enclosed triangles. This implies that the sum of interior angles of a square will be equal to twice the sum of interior angles of a triangle. Now let us locate the interior angles of our square. Okay, so angle. Okay, so you can see our square with 90 degrees in each of its interior angle. This will give us the sum of all interior angles to be 360 degrees, which is twice the sum of interior angles of a triangle. We can do the same for pentagon. Now let us divide our pentagon into enclosed triangles. Get the line segment, then we draw from that point up to here, and another line segment from that point up to here. We can count now the number of triangles from this pentagon. We have 1, 2, 3. This implies that the number, the sum of the interior angles of a pentagon is equal to 3 times the sum of interior angles of a triangle. Now let us locate the interior angles of our pentagon. Get angle from here, then we locate. Okay. Okay, so each of the interior angles of our pentagon is having 180 degrees, which will give us the sum of 540 degrees. So that is the 3 times the sum of the interior angle of a triangle. We can also use the same procedure for hexagon. You can divide the hexagon into a closed triangle, then the number of the triangles in the hexagon will be multiplied by 180 degrees to get the sum of interior angles of our hexagon. Get the line segment. From there, we draw from this point up to here. We can also draw again from that point up to here. We can also draw again from that point up to here. So we can count now the number of triangles we have in our hexagon. 1, 2, 3, 4. This implies that the sum of interior angles of our hexagon will be 4 times the sum of interior angles of a triangle. And we can locate now the interior angles of our hexagon. So as we can see, each of our interior angle is having 120 degrees. This will give us the sum of 720 degrees for all interior angles of our hexagon. From this all, we can now get the formula of calculating the sum of interior angles of any polygon, and that will be the sum of interior angles of any polygon equals to n minus 2 times 180 degrees, where n is the number of sides of a polygon and 180 degrees is the sum of interior angles of a triangle. Thank you for listening. We can end up here.